I'm Dale, and this is What's New in Generative AI. And boy, is there a lot of new stuff to talk about in generative AI at Google, especially for developers. In this talk, we'll cover Google's new PaLM API and show you how to build your own generative AI-powered applications, both in the browser and in code. But first, what is generative AI? Generative AI is a broad term that returns to machine learning models that generate content, like imagery, sounds, videos, and text. And today we'll talk about models that generate language. Now, you might have heard of these text-generating models called LLMs, or large language models. An LLM is a neural network that takes as input text, something like "it's raining cats," and produces as output words that are likely to follow. In this way, it's kind of like the world's fanciest autocomplete. How does the LLM predict which words are likely to follow? Based on statistical patterns it's learned from its training data. So for example, an LLM trained on poetry is likely to produce poetic-sounding output, but an LLM trained on code is likely to produce output that looks like code. But today, we typically train large language models on huge, diverse data sets that contain all sorts of text, which means that LLMs tend to be good at a wide variety of language tasks, so one single model can power lots of different language applications. And what kinds of language applications am I talking about? For one, LLMs let us quickly solve many classical natural language problems like entity extraction, text classification, summarization, sentiment analysis, and translation. But they're also capable of solving a whole new class of complex, nuanced language tasks like explaining humor, or even creative problems. Not only are LLMs helping us solve new problems, but they're also helping us prototype AI-powered applications faster than ever. And that's a big deal. If you're an ML person, you know that before LLMs, whenever we wanted to build any kind of NL-powered application, we typically needed to collect thousands or hundreds of thousands of training examples, and that could take weeks or months. But with LLMs, no longer. We can go from thinking up an idea to prototyping it in a matter of minutes, and you don't even have to be an ML expert to do it. Which is what we're going to talk about today: how to prototype LLM-powered apps fast using Google's new suite of generative AI developer tools. Like the PaLM API, which gives developers access to Google's latest LLMs, all hosted in the cloud. You can use the PaLM API in Python or JavaScript or your favorite language. But before we jump into the code, we're going to access the PaLM API through a browser interface called MakerSuite, which looks like this. It's a browser-based visual interface for prototyping with the PaLM API, so we can try out the LLM without downloading or installing anything. Now, in traditional ML development, to prototype an idea, we typically need to train a model on a large dataset. But to prototype with an LLM, and this is the really incredible part, we only need to write, telling the LLM what we want it to do in regular old human language. In LLM parlance, this is called prompting. Prompting is the art and science of writing input text to guide an LLM to create the kind of output that you want. Let me show you what that looks like in MakerSuite. First, I'll create a new text prompt. This interface lets me type text that gets sent directly to the underlying model. One effective way to build with LLMs is to instruct them. So I can write something like, "Help me plan a theme party." This is called a zero-shot prompt because we're telling the model what we want it to do, but not showing it any examples. But sometimes an even more effective technique can be to show an LLM how you want it to behave through a handful of examples. For example, let's say I want to build an app that takes a paragraph and summarizes it into a bulleted list. I'll do this by creating what's called in MakerSuite a data prompt. Data prompts combine instructions with examples. So up here, I'll write an instruction, take the text and summarize it as a bulleted list. But then I'll also include some examples of output paragraphs and output summaries. This is useful for when you can't encapsulate everything that you want the model to do in a single instruction. By giving examples, I can show the model about how long the list should be and what kind of style it should use in the summaries. Now, when I feed a new paragraph into MakerSuite, voila, it generates a summary list. When I finish writing my perfect prompt in MakerSuite and I want to move to code, I can click the Code button and export this to Python, JavaScript, or another language. So we've talked about how prompt engineering is a great way to prototype something quickly. Again, nothing quite like this has ever been available before in ML. However, prompt engineering alone has some limitations. You can only fit so many examples into the context window. And also, LLMs can be very sensitive to changes in the text in the prompt, including the exact wording of the examples. Plus, LLMs can sometimes produce unexpected output, especially for structured use cases. We really want the model output to be more predictable. So what can we do to improve the quality of the apps we prototyped with prompt engineering? We can turn to a technique called parameter-efficient tuning. Parameter-efficient tuning is a way of customizing the behavior of LLMs using your own training data. If you're a traditional ML engineer, you're probably familiar with the concept of fine-tuning a neural network on your own custom data. Parameter-efficient tuning is similar to fine-tuning, but with one major difference. It makes tuning efficient for very large models by allowing us to not tune every weight in the model, like we do with fine-tuning, but instead to tune just a part of the model, a part that we can swap in and out at inference time on top of a single underlying LLM instance. That way, we can modify just a small number of weights for each end user while depending on a single underlying LLM instance. So take our summary list maker. It works pretty well out of the box just with prompting, but let's improve its fidelity by doing some parameter-efficient tuning. To run tuning, we'll need some training data. Now, the nice thing about parameter-efficient tuning is that, because it's building off the incredible multi-purpose capability of the underlying large language model, we don't need very much data to run a tuning job. Hundreds or even tens of examples compared to the thousands or more we typically need for fine-tuning. But still, where are we going to get training data to tune our model? Well, it turns out, believe it or not, we can actually use LLMs to generate tuning data for us. This is called synthetic data generation, and it's a feature that's coming to MakerSuite soon. Let me show you what it's going to look like. In MakerSuite, when we've already written some handwritten examples, we can add generated new examples. So when we click the Generate button here, the PaLM API under the hood generates examples that looks like the ones that we gave it as input. And then we can add these generated examples back to our dataset and use it to run a tuning job. Now let's take a step back. What we just built is a system that takes as input a paragraph and summarizes it as a bulleted list. But sometimes what we want is not just an input-output system, but to have an actual conversation with a back and forth. In other words, we want to build a chatbot. Chatbots are one of the most common applications of LLMs. If you use Bard, you've had a conversation with an LLM firsthand. Now, from a developer perspective, building chatbots is a little more complicated than building a text input-output system like the one that we just prototyped. That's because conversations have state. We, the user, send a message to the model produces a reply, we send another message, and in doing so, we produce a conversation history. What that means is that the prompt that we send to an LLM when we want to build a chatbot includes the conversation history, every single message sent between the user and the bot. And this history grows, and we add new messages to the prompt as the conversation goes on. But luckily, the PaLM API's chat service handles all of these complications and makes it easy to prototype chatbots. Let me show you how. Here in MakerSuite, I'm going to create a new chat prompt. As a reminder, MakerSuite is just a graphical interface to the PaLM API, so whatever I'm doing here in the browser, you can do in code too. A chat prompt contains a couple of different sections. First is the context. This is where you can write an instruction telling the model how you want it to behave. So we might say, act like a pirate and speak in pirate lingo. Next, we can provide some example exchanges showing the model the types of answers we want it to give in response to user input. All right, now that we're done, I can test out the chatbot. Voila, we've prototyped a bot that speaks like a pirate. Now, while a bot that talks like a pirate is fun, there are lots of business applications that can benefit from LLM-powered chatbot interfaces. Everything from customer service agents to personal assistants to product recommendations to interactive storytelling and a whole lot more. Or you can make a fun word game, like this one called Quick Prompt. It's a guessing game where I, the human player, have to get the model to guess my secret word. But what does it actually look like in code to go from a prompt you design in MakerSuite to an actual working application? Let's take a look at how to build with the PaLM API in code.
Thanks, Dale. This is a really exciting time in machine learning, and you can use the PaLM API to develop an entirely new class of applications with just a few lines of code. I'll show you how to get started with 3 cool examples. First, you'll use the API to help you create a reverse dictionary. You'll provide the definitions, and the API will guess the word. Next, you'll create an interactive application. You'll configure the API to pretend it's an alien that lives on one of Jupiter's moons, and you'll ask it for travel tips. Finally, I'll show you how to create an application that can answer questions about your own data. You'll use the PaLM API to talk to a document. You'll ask a question, and you'll get an answer. OK, let's get started. Let's head back to MakerSuite, and imagine you have a prompt designed, and now you'd like to get the code to call the API in the same way. The easiest way to start developing is by clicking on Get Code. And right off the bat, you can see code examples for Python, JavaScript, and command line tools like curl. That's because the PaLM API is a REST API, and you can call it directly if you like, or even better, you can use one of the user-friendly client libraries for Python, JavaScript, Java, and Swift. Now, the API has 3 endpoints, and these correspond to our 3 examples. The text endpoint is optimized for short interactions, and you'll use this to build the reverse dictionary. The chat endpoint is designed to help you create interactive multi-turn applications, and you'll use this to chat with an alien. The embeddings endpoint is for developers, and it can help you represent text in a way that a computer can understand, so you can build new applications for things like search. Let's take a look at a code example for the text endpoint, starting from scratch. First, pip install the client library, and next import the PaLM API. Now call palm.configure with your API key, and we've made it super easy for you to get a key. All you have to do is go to MakerSuite, click on Get an API Key, and copy and paste it. The PaLM API has a few different models available, and you can see a list of these by calling palm.listModels, and you can read more about them by visiting our website. Once you've selected a model, you can write your initial prompt. And now let's call the model, and we'll print out the result. And that's the simplest way to use the API. Now there are a couple more options you can explore. One is called temperature, and it lets you control the degree of randomness the model uses to generate a response. When the temperature is 0, the model will return the same response every time. But when the temperature is closer to 1, you'll see more variation. You can also change the candidate count parameter, which tells the model to return multiple responses sorted descending by confidence. And you can explore them in completion.candidates. Now let's see how to use the chat endpoint to develop an interactive application. It's similar to what you just saw. The main differences are the method you call and how you handle the conversation history. Instead of calling generate text, you'll call chat, and you'll send a message to the API to start your conversation. Here, for example, you'll say, "Hello, good morning." Now, just having a general conversation is fun, but you'll probably want to configure the API to have the right kind of conversation. And to do so, there are 2 fields you can set, the context and the examples. Let's use these to configure the API to pretend it's an alien. First, let's set the context. It's like a hint you send to the model to tell it how you want it to behave. Next, let's provide some examples. And these show the model example chats and how to respond. And typically, you should provide at least 3. Here we'll add one that talks about the alien's home. Now you can call palm.chat with these fields to start your conversation. And you can see the model's response by printing it out. The response object contains the full conversation history, which you can see in the messages field. And for convenience, you can access the latest response by calling last. And you can continue the conversation using the reply method. Let's ask the model more about its home. You can see the conversation history by printing out the messages. Now you might be wondering, why did we include the context and the examples in a special field? That's because language models have a limit on the length of text they can handle as input. As the conversation history grows, your prompt might get so long that it exceeds the input window length. And if this happens, messages are truncated in a last in, first out order, but the examples and context will remain set. Now the embeddings API is powerful, and I think you'll have a lot of fun using it. If you're new to embeddings, they're a way to convert words, phrases, or even entire paragraphs into a vector or an array. And the key idea is that similar passages will have similar embeddings, and by comparing these, you can build applications for search. Now, if that seems a little abstract, that's totally okay. And let me show you an example to make it concrete. And you don't need to know the details of how the embeddings are created by the model to use them to build applications. Imagine you have a web page like tensorflow.org, and you have a question like, what's the latest version? You can use the embedding endpoint and the text endpoint together to ask and answer this with natural language. So how does this work? The first step is to use the embeddings endpoint to retrieve embeddings for each paragraph from the page. And you can generate an embedding in a single line of code. Now, once you have the embeddings for the page, you can get embeddings for your question. Now you compare the embeddings of your question to the embeddings for each section to find the area of the page that uses similar language and might contain the answer. Then you can use a clever prompt with the text endpoint, and you can find complete code for this on the website. I know this is pretty fast, and send your question and the section of the page to the model to get your answer. And there's another important use case for embeddings, and they can help you with your open source machine learning projects. You can use embeddings to train a classifier with less training data than you normally would need. And the key idea is that rather than starting from plain text, you can retrieve the embeddings from the PaLM API for the examples in your training set and for the examples you want to classify. And you can apply the knowledge the language model has learned on your own data. Now, there are many additional use cases for embeddings, and these range from information retrieval to recommendations to question answering. And we'll be adding more examples for you in the coming months. There's one more tool I'm excited to show you, and that's Colab Magics for large language models. And this makes it easy for you to access LLMs in Colab with a single command. This is great for new developers, especially if you need more control than MakerSuite, but you aren't quite ready to write lots of Python. I think you'll like this a lot. If you're already a Colab user, you might have played with the Magics before, and these are little shortcuts that make it easy for you to connect to external tools. And we've added one for the Palm API. All you have to type is %% followed by your prompt, and you'll see the response in a pandas data frame nicely displayed in Colab. We've also connected the Magic with Google Sheets to make it easy for you to work with lots of data without having to write much code. For example, let's say you want to prompt a large language model to find the opposite of a list of words that you have in a spreadsheet. You can use a magic command that reads each row of the spreadsheet, automatically inserts it into a variable, calls the large language model, and writes the results to a table or even to another spreadsheet. There's lots more functionality you can check out, including tools to let you include Python functions as you're ready and to compare and evaluate prompts. And this is a fast and efficient way of experimenting with large language models, and I think you'll really enjoy it. OK, you've just seen how easy it is to prototype with MakerSuite and develop with the Palm API. And these tools are the best place for developers to get started. When you're ready to scale up your application and get enterprise-grade support, you can build out your application on Google Cloud. And Vertex AI's Generative AI Studio gives you access to the same family of models as the Palm API and makes it easy to integrate with the rest of the Google Cloud ecosystem. So be sure to check them out when you're ready to go to production. And with that, I'll hand it over to Laurence.
Thanks, Josh. We've heard a lot today about large language models and about how you can use them. From tools like MakerSuite to help you with getting the most out of the foundational models, to APIs like the Palm API that you can get more fine-grained control with. But there's one more topic I'd love to explore with you, and that's using models like these responsibly. Over the last few months, we've seen what can happen when people interact directly with large language models. And there are scenarios where they empowered great productivity, as well as ones where, through misunderstanding, unintended harm could be caused. For example, what if you created an app that helps writers get inspired when creating scenes for their book? It's a perfect use for a large language model. But what if they're writing a children's book and you give them content that's inappropriate for children? That could be harmful. So at Google, we've been working towards showing you how you can leverage these foundational models in your app or business in a way that's responsible and constructive. There's 3 steps to doing this. The first is to have principles on which you operate. And at Google, we've created our own set of AI principles, which you're free to use as inspiration for your own, of course. They're based on our overarching mission, and they include goals to be socially beneficial, avoid unfair biases, be safe, accountable, and private. And all this while upholding standards of scientific excellence and being made available for uses that accord with these principles. And large language models are no exception. If anything, we've learned that their popularity means that it's very important to have a foundation of principles to work from. The second step is to publish common solutions to common problems. This is a nascent field, so these will grow in time, but we've started that process at I/O, and I'd like to share some resources on this with you. First, check out the talk on safe and responsible development with generative language models that you can find linked in the description below, where Google researchers share what they've learned from building our models. Also, if you get a chance to check out the Google I/O keynote, we shared this fun card game that we created where character descriptions were generated using large language models. But we put guardrails on this to ensure that the text would be appropriate, and how we built that is documented in the links below. The third step, of course, is to build tooling to accomplish your goals. The Palm API, for example, comes with built-in safety filters to block certain kinds of unsafe output. While there's some output that we will always block, we're also giving developers the ability to customize safety settings. Here, you can configure how permissive or how restrictive the model is in producing text along different axes, and you can choose the settings that are most appropriate for your application. However, do note that if you want to change these safety settings from their defaults, you should use caution and thoroughly review any impact on your critical user journeys before you publish any applications. By following these 3 steps, first, having a set of principles, then having published discoveries and examples about how to implement them, and finally, tooling that scales to many scenarios, I believe you can really bring the best value out of generative AI for you, your customers, and the world. And as we move into the next phase of computing and AI, where applications will be built on top of generative models, be they language, graphics, or many other scenarios, I think you'll be well positioned to really make a change for the better. It's going to be a fascinating journey, and I'm really glad you're taking it with us. Thank you.